All right, well, hello, 7th hour physics students, and welcome to another video lecture. This video lecture is going to take the form of a debrief of the knowledge check that we worked on yesterday, and that ideally you finished. If you did not, do not worry about it. Again, this was just for me to kind of go around and see and take a look at how we're doing in terms of the process of computer-aided graphing. But what I really want to debrief today is questions 3 and 4, okay, from that knowledge check, because questions 3 and 4 introduce us and get us thinking about where we're going with this stuff. So again, computer-aided graphing is a process. It's a skill. What we want to be able to do is we want to be able to analyze the data based on the graphs that we create, based on the data sets that we have. Okay, we want to create meaning between these variables based on those things. So that's what we're going to start doing today. So first things first, obviously I had you graph kinetic energy versus average velocity. You should have seen when you did that your graph was parabolic, okay? So I kind of made that step pretty obvious here, because then I had you graph kinetic energy versus average velocity squared. And if you did that, you got a nice linear relationship there between those variables, okay? Between kinetic energy and velocity squared. So keeping those graphs in mind, let's take a look at number 3. So keeping those graphs in mind, I asked you what the KE equation was. Is it 1/2 mv or is it 1/2 mv squared? Well, we don't have to make this complicated. All we need to look at here is which variables created a linear shape. We always want to relate things to our slope-intercept form. Y equals mx plus b. Okay, now we don't really have to worry about the y-intercept here, this b, because our y-intercept is 0. So really what we want to focus on is this, as it relates to the variables that were graphed. Well, when we graphed KE here versus V here, we did not get a linear shape. It didn't follow our slope-intercept form. But when we graphed KE versus velocity squared, it did become linear. So that tips you off that what we should have here is KE is equal to 1/2 mv squared. Okay? Now, question 4. This is where we can continue to draw meaning and learn some stuff about a particular experiment based on the graph data. Okay, so what I'm asking you for here is, using that slope that we see based on our trend line equation right here, what is the mass of the object? So what I want us to do here is I want us to compare our slope-intercept form here to our KE equation that we determined from question 3. So the questions that you need to ask yourself, okay, in my graph, what were my y values? Well, my y values were kinetic energy. So you should see here that these two are aligned. Okay, what were my x values? My x values were velocity squared. So here we go. These are aligned. So now what is left over? What is our slope actually equal to? Our slope is equal to 1/2 mass. Now, don't get confused here. Remember, in slope-intercept form, this m is the slope. It's not the same as this m. This m is mass, okay? So notice the connection here. Y values line up, x values line up. Whatever's left over, that is what your slope is equal to. So we can actually calculate what that mass value is now. I know that my slope value was equal to 0.261, and that's equal to 1/2 mass. Therefore, mass is equal to 0.522. Okay? And our units there would be kilograms. I'm not expecting you to know that, but that is what our mass units are always going to be. Okay? So there is the process of how we can pull information out of this graph data, find unknowns, and create meaning for a particular situation or experiment based on just a data table and a graph. So your job now is to open up the document that is posted to today's Google Classroom post, create a copy, and work through each problem. Some of the problems, I just give you a data table. You have to create a graph, pull meaning from that graph based on the process that we just went through. Some, you're just going to see a graph, and from there you can analyze the graph, find unknowns, create meaning. Again, what we've been doing the last few days is the skill. It's the process of computer-aided graphing. Now we're learning this idea of data analysis, and we're trying to mesh the two together to prepare us for experiments that we do throughout this school year. Okay? So do your best on the stuff, on that assignment or that activity for today. You do not have to submit it. We're going to debrief all parts tomorrow. Okay? Take care, 7th hour. We'll see you tomorrow.